So welcome back to this video. So in this video, we'll be focusing on foundations of computer vision. So throughout this video, we'll be discussing about how computer vision have been evolving from classical approaches to deep learning approach. We will discuss about some of the real-time applications as well as we'll discuss on what kind of tools we'll be using for the computer vision development as well as deployment eventually. So in earlier days, from 1960s to 1990s, there used to be like a lot of rule-based approaches and handcrafting the feature extractions and all those approaches. There were no large data sets, no GPUs, computations were very slow. Everyone was solving the computer vision problem in terms of like performing the edge detections and Sobel filters and canny edge detections and watershed algorithms at that point of time. It was okay, but if you start like changing the lighting conditions of the video or images, then the performance used to be like not performing as much as expected. So then came the local features, shift, surf and orb. So here we'll be having like some sort of like key points, like which key points are important for the recognizing an object or for classification purposes. Again, this is completely one of the limitations is manual designing. So you have to design it manually, like based on what kind of images you have, and then again, if something like a lighting changes or pose changes, then the problem is like you have to change the design one more time and go for finding the which key points are important. And again, so this is from 2000s to 2010, and then the deep learning revolution came across. So we have like from 2012 to current. So AlexNet won the MHNet competition in 2012, and then we instead of handcrafting the features, we started learning everything through the data. So we had access to massive data sets and much faster GPUs. So we started extracting the features automatically using the CNN models. So CNN is nothing but convolutional neural networks. We'll discuss about them later. And there were other architectures as well, like VGGNet, GoogleNet, and ResNet. And some of this, at this point of time, some of these architectures that we have talked about are used as a backbone architectures. I know you don't know what backbone is yet, but we'll discuss about that eventually. So currently, we use like ResNet, EfficientNet, and Vision Transformers as backbone architectures, and we perform several computer vision tasks such as classification, detection, object segmentation, and post estimation, and all. And we do have some of the self-supervised learning approaches called Dino, MAE. So we'll discuss about all these things later point of time. So CV in the AI first era, so that is like from 2023 from to 2025. So there were two big shifts. One is multimodal AI came into picture. So we have clip and blip and all those kind of models. And we do have generative models such as diffusion models here. Like we have stable diffusion and latent diffusion models and all. And we have some of the foundation models. We have like a pre-trained vision transformers, like we have vision transformers that are pre-trained. And earlier days, it used to be difficult to have any sort of computer vision model deployed in a edge device, but now it has become more simpler and more easier for us to use edge devices like some tools like NVIDIA Jetson and Coral TPUs. So these kind of GPU-enabled machines will be helping you in real time for the edge devices to process the computer vision application. So, where do we see computer vision in 2025 or even at this point of time, right? So, we have healthcare applications, we have retail applications, and several other places we use computer vision. So, let's get into where we exactly use healthcare, computer vision in healthcare, right? So, we have something called medical imaging. So, we can have X-ray of your skins, X-ray, CT scan of your I don't know where exactly we use CT scans, but MRI for sure, like medical resonance imaging. So you have you'll be, I mean, CT scan is like you can perform it on head and all those places, and here you can find the X-rays like in the skin or skin. You will not do able to do the skin. I mean, you'll not be able to do the skin X-rays on skin, right? So okay, fine. So based on these images, you will be able to perform the cancer detection. So whether there is an lesion in the skin or not, or what kind of issues are there. So we can use the radiomics data and use this. And second one is vision guidance. Like we can use computer vision for guiding through the robotic procedures we can perform on top of patients. So It's becoming famous at this point of time. So you can see like a lot of robotic surgeries have been happening at this point. So a small camera is sent inside the body, and then we can use robotic guidance to help in terms of the surgeries and stuff. And second one, the next one is retinal image analysis. So based on the image of the data eye, you'll be able to find whether patient has diabetic retinopathy or not. So you can go for diabetic screening through retinal image processing as well. So next one is retail application. So from Amazon Go style, you will be able to perform the shelf monitoring, like how many products are there on the shelf and how the customers are behaving through their poses and their movements. And you will be able to use the AR try-ons to put on your dresses without having to manually put on the actual clothes. So you can have a lot of these applications. You can try these things on with the help of computer vision at this point of time. Next one is surveillance and security. So you can have the smart CCTVs with anomaly detection. So if someone is doing something seriously anomalous, then you will be able to find out through the CCTV. Like you can process through the videos and see like if any anomalous behaviors are noted in the video or not. And let's say like you can think of some of the toll places where you'll be clicking pictures of the, I mean, the cameras would be clicking pictures of the license plate. So you can make use of that for charging the person, like how many times they have crossed the toll places. So based on the license plate recognition algorithms, and we can use the person re-identification, like who the exact person is and why exactly he's suspicious and all those things. And you can estimate the density of the crowd, like based on like how many people can be accommodated here, just using the computer vision process. And one more problem with this is you cannot just go deploy these things. You have to have some sort of approvals because the law enforcements are also being in place. You cannot just go identify a person with their with your computer vision model, or you cannot go get the CCTV and then try to find the anomalous behaviors or identifying the person or get the license plates and all those things. So there should be some sort of approval in places. Next one is AR, VR, and metaverse. So you'll be having some sort of real-time environment mapping. So you'll be, if you think of robotic vacuum cleaners, so they'll be like moving around the house, and then they'll be able to map where exactly what kind of items are there and which one is exactly the a hard surface or which one has a carpet on it. So you'll be able to use that data to map the place and then be able to travel across the house without colliding with any other objects in the house. And we will be able to perform the hand gesture process as well. Like if you see, you can have some sort of like VR headsets, and you will be able to virtually perform the hand gesture to control the scene, like 3D construction of the scene. And we can also use the eye tracking for like whether you're trying to move towards the other side or left side or right side or whichever the places that you want to see by tracking the eye movements. Next one is my favorite topic. So this one is automotive and transportation. So I have been working on a lot of automotive based perception stack. So if you look into the latest any of the autonomous vehicle companies, they all make use of cameras for sure. Of course, lidars are needed. In some companies, they try to avoid the lidars as well, but it's their personal choice. And let's see how that provides the safety for the pedestrians as well as the other road users. But let's not dive into it because that is not the topic of discussion at this point of time. But yeah, so we'll be able to identify if there is any other road user is violating the laws or not. So these kind of violation can be detected, and we can monitor the traffic, like if someone is not stopping for the red lights or not. And we can also work on some of the use cases such as driver monitoring. So if the driver is paying attention to the road, or he's just using the mobile phone, or he's being distracted at this point of time, or he's feeling drowsy at this point of time. So these kind of things can be automatically detected using the computer vision part. Like if there is a camera that is pointing to the face of the driver, that will be able to detect like if the attention is completely there on the road or not, right, on the wheel or not. So these kind of things again, like I'm not going to discuss about whether it is allowed or if there is a privacy violation is there or not, but I'll just touch upon the use cases where you can perform these things, right? And next one is pedestrian and cyclist detection. So many times I have noticed whenever there is a driver who's trying to make a right turns or something, there'll be some pedestrians crossing the road. So at that point of time, the pedestrian will be having a go signal for the pedestrian to walk, but the driver doesn't know because driver assumes that there is no other vehicle on the left side, so you'll be able to good to go for the making a right turn. If the driver is not in a good speed to control the vehicle, then that's going to be a problem for the cyclist or the pedestrian who is trying to cross the road on the other side. So this is a typical scenario for the safety improvement. And so these are the things like we have seen so far. Like we have talked about couple of use cases right now that are there at this point of time. And these are the tools we'll be using throughout this coursework. So we'll be discussing about some of the how do we use a code, like how to version control in GitHub, and we'll discuss about like how we can run the algorithms in Google Colab, which is powerful literally at this point. And we'll also get some of the Kaggle data sets. We'll discuss about like some of the pre-trained models from Hugging Face, and we'll go through some of the data sets that are there in the RoboFlow, and we can also work on hands-on CVAT. So CVAT is nothing but another computer vision annotation tool. So we'll be using that, and we will discuss on Label Image Studio if possibly, if time permits. And Ultralytics is another uh, mainly they focus on the YOLO models. If you see, like they also have some other projects actively going on, but if you see, like many of the recent YOLO models, they are coming from the Ultralytics papers, so you can definitely go through them. And OpenCV is used for the image processing, so we'll discuss about that. 51 is for the visualization, so we'll visualize some of the images using that. And then finally, we'll have the deployment. Possibly, we can run the models in AWS SageMaker as well, if time permits, but definitely you will have enough experience in terms of like hands-on as well as the theoretical part here. So, summary of this, we have discussed couple of use cases where exactly the computer vision make a play a role, huge role actually. So we'll master this course will be helping you in terms of accelerating your computer vision journey, and definitely we can help you in landing a computer vision career. So if you follow the series, you will be having like a lot of hands-on experience in terms of the Python programming or C++ programming, as well as you will have a strong grip in terms of running through the code. I mean, solving the mathematical problems that are there in the computer vision, and you will be having much more. You'll be feeling much more confident enough when compared to any other courses if you go through this series. And I just wanted to like I could have given the course in Udemy, but I just wanted to make sure it reaches to everybody so that they will be able to shine in their career. So stay tuned, stay in touch. Thank you so much for watching. Please let me know if you have any questions. Uh, Thank you. Bye.